Thermodynamics. Today we'll go through another important property of the system, that is internal energy. The internal energy means the total energy of the system. What do you mean by the total energy of the system? That means total energy of the atoms or molecules of the substance contained inside the system. So the atoms and molecules inside the system, they are not in static position. They are always in a motion or in a vibration or in rotational motion. So, or some binding energy is there, or some energy of the particles due to their positions. So due to these factors, we will count or all all sorts of energy inside the system. So that is why the sum total of the energy of the system, sum total energy of the system is sum of the translational kinetic energy, rotational kinetic energy, vibrational kinetic energy, nucleic energy, electronic energy, and molecular interaction energy associated with the atoms or molecules of a system. So what do you mean by the translational kinetic energy? Due to the linear motion of the molecules, gaseous molecules inside the system, it may contain some amount of translational kinetic energy. Similarly, rotational kinetic energy, due to the rotation of the molecules or atoms, and vibrational energy means the atoms fixed at a position inside the solid, they vibrate along the meaning position. It contains some part of vibrational energy. Nuclear energy means that energy binding the nucleus, holding together as a nucleus. Similarly, electronic energy means the electrons are revolving around the nucleus in certain velocity and having position to their to the nucleus, respective nucleus. So that is why they contain some amount of electronic energy. That energy counted is called electronic energy. Then the molecular energy, this is due to the chemical bonding existed inside the molecule. It also contains some amount of uh, molecular interaction energy. That means due to their position, they possess some amount of energy. So all such energy, some of all such energies are internal energy. So the internal energy, in to well define the internal energy, it is the sum total of the translational kinetic energy, rotational kinetic energy, vibrational kinetic energy, nuclear energy, electronic energy, and molecular interaction energy associated with the atoms or molecules of a system. It is denoted by E. E is equal to Et plus Ej plus Ev plus En plus Ee plus Ei. Et means translational kinetic energy, Ej means rotational kinetic energy, Ev means vibrational kinetic energy, En is the nuclear energy, and E is the electronic energy, and Ei is the molecular interaction energy. So the absolute value of the internal energy cannot be determined because it is impossible to determine the exact value uh, mm, of the internal energy of a system. So the internal energy is a state function, because state function, why it is a state function? State function means it depends on only initial and final state of the system. This is because it depends on initial and final state of the system and not on how it attains the state. That means it is not depends upon the path. It depends upon the initial state and the final state. Hence, the change in the internal energy depends on only initial and final state of the system, not on the intermediate states. So you can denote the internal energy is delta E, that is the change in internal energy, change in the internal energy that is at final stage and initial stage. So that is called delta E is equal to internal energy at final internal energy and initial internal energy. That is the change in internal energy. So next we go through these characteristics of the internal energy. What are the characteristics? Internal energy is an extensive property. Why it is called extensive property? Because it depends on the amount of substance contained in the system. The amount of substance, if it is varied, then the extensive property will change. So another thing is this internal energy is a thermodynamic state function because it depends upon the initial and final state of the system, don't depend upon the process of path, and it is independent of path followed. The internal energy has complete differential, means dE differential of E, that is dE integral limit E1 to lower limit E1 to upper limit E2, dE is equal to E2 minus E1. So we can find in infinitesimally slow or small amount, we can find out this. Similarly, the absolute value of the internal energy cannot be determined. I have also told that it is not possible. The amount of internal energy depends on nature of the constituents and modes of burning. The amount of internal energy depends on the nature of the constituents and modes of burning. Another thing is the amount of internal energy of a given system is different under the given set of conditions of thermodynamic variables. So the change of internal energy is difference between final internal energy and initial internal energy. Delta E is equal to E2 minus E1. So E2 is the final internal energy and E1 is the initial internal energy. The sign change of the internal energy, that means what is the sign? Sign will be negative. The internal energy is positive when E2 is greater than E1. Final internal energy is greater than initial internal energy. If the final internal energy is less than the initial internal energy, then it is negative. Regarding the units of the internal energy, it is joule in SI system and arg in CGS system. So what is the significance of internal energy? In thermodynamics, we will go in detail, but you remember that at present, you remember that internal energy is equal to the exchange of heat energy between system and surroundings when the It is maintained at system and surrounded constant temperature and constant volume. It is constant temperature and constant volume. In this condition, the change in internal energy is equal to the heat supplied at constant volume. So the change in internal energy in chemical reaction. A chemical reaction is also a chemical system inside which a chemical reaction takes place. So we take if consider the internal energy of the reactants, and after the reaction, it is converted into product. If we count or we will determine the internal energy of the product, that is different from internal energy from of the at initial, that is for reactants. So the internal energy for reactants and internal energy for products are not same. So the difference of the two is your change in internal energy. Delta E is equal to EP minus ER. EP is the internal energy of the products and ER is the internal energy of the reactants. So here your change in internal energy is positive when EP is greater than ER and is negative when EP is less than ER. So this is all about the internal energy, and in the next class we'll go through another section, that is laws of thermodynamics. Zeroth law of thermodynamics, second law of thermodynamics. All details we'll discuss in next class.